Yes, it's recording.
Thanks. I probably shouldn't, because I don't even know what I'm about to say. Alright, we're skipping to 4. Radian and degree measures. Ever heard the word radians?
Yes. Is it on my calculator?
It's on your calculator, yeah. Remember in geometry when you had to make sure your calculator said D on the top instead of R, otherwise you get the answer wrong.
I never know how to do that.
Or it had to say DEG instead of rad, otherwise you get the answer. Yeah, a radian is just a way, another unit for measuring angles. Like, if I go like this, you can't see me in the video, what degree is that angle?
180. Oh wait.
90?
That's a 90-degree angle, right?
This is not
That's not a 90-degree angle. Can you put
Put
this
your arm
arm
up
closer?
higher.
This
Don't
one?
look at my head. I can't see myself. Shut up.
It looks like an opposite.
Bad
angle.
example.
It's okay, I got
But
the email.
so radians are another, like that would be pi over 2 radians. It's just a way of measuring angles.
So it's like degrees.
Yeah, it's like feet and meters, just different units for the same thing.
It's different units degree.
Yes.
Okay.
So, here we go. Do you know what this is?
A line.
That is not a line.
Line segment.
Segment.
It's not a line segment. It's a ray.
Oh, there you go.
Yeah.
One of
It's a
those.
point, it goes one direction forever, that's a ray. So
Geometry.
when we're talking about the measure of angles, they're always gonna kind of, you're gonna start with a horizontal ray going to the right, and the angle's gonna open either up or down. This is the kind of confusing part. So if I take this ray, and then I grab another ray, and I rotate it up, I've created an angle now. That's it. It's the gap between two rays, right? Right?
Right.
Right.
Right, alright. When we do this, this is called the initial, this was our initial side. That's the side I started with. And then I rotate it up, and then whenever I stop, that's called the terminal side. So what's terminal mean?
Finish.
To end, yeah. So it's like, oh, I'm going to take my hands, here's my initial side, and now I stop. So I got a terminal side and initial side. This would be a positive angle. We can have negative angles in this. If I started with a ray like this and rotated down, like that, I still have my initial side and my terminal side, but now this would be, when we say the measure of that angle, it would be negative. We'll have a negative value if we go that way. The confusing part about that is what if I said, okay, I start here and I go all the way around to right here and I'm looking at this angle? That would be a positive angle. That would be negative if I go this way.
Are those arrows always going to be there?
Yes.
So you could be able to see it and know if it's positive or negative?
Yes.
Alright.
So let's talk about what a radian is. Because then we'll start saying how big is that angle. We'll start measuring them. Not with a protractor, but just, you'll see. Radians, what is a radian? I don't know. Here, you want the definition of a radian?
No.
Yes, you do. It's the measure of an angle. I told you that. We'll call that angle, what's that say? Theta, yeah.
Hey, I remember something about
It's the measure of an angle
I know I still can't do something about it.
that intercepts
I know.
an arc
I don't know how to solve it now. I can tell you things.
S equal and line to radius. Now this is very confusing. Should write it down and then I'll explain what it means. You might be wondering, what circle? What are you talking about, a circle? When You know what an arc is? Not the bow. Yeah, it's a portion of a circle, right? It's a sector of a, not a sector, because that's like a piece of pie, but just the outside portion of a circle. And it's not the whole circle, it's just a piece of it. So to talk about this definition, let's say here's our ray, and here's our angles. Well, a radian is defined as, you're going to have an arc between these, and that arc is part of a circle. See if I can draw a circle.
Why didn't you draw the circle first?
Yeah, I should have. So my angle is theta.
Is this for calculus? Is what you're teaching us?
Yeah. The radius of the circle is right here, and the arc length of the circle is right here.
The radius is half the diameter.
Yes, the radius is half the diameter. I was trying to figure out what Janelle was saying. We don't care about the diameter yet. All we care about is if S equals R. So that's if this arc length is the exact same as the radius of the circle, that is 1 radian. So that's how you define a radian.
So the radian can change depending on the circle?
Yeah, you can have 1 radian, 2 radians. It's a
So
way.
it's like scale factor kind of?
No, it's like degrees. But you know, if I said what is 1 degree, you'd be like, oh, like this much.
No,
Well, how
but
do
the
you know
radian-
that? Define a 1 degree.
The radius size can change depending on the radius of
The size of the
circle.
circle, the
So-
angle. You can measure it in a different spot. You can bring it out.
So as far as it's
Those
always
all
going to
those-
be 1 degree.
Have a relationship
So if the
there.
radian is like 12 and S is 6, does that mean,
If the radius was 12 and S was 6,
is that 2?
that'd be like a half a radian.
Oh, so
But what if like a
Divided?
different
Yeah.
circle?
you would have done anything? I don't know.
What if in
Yeah.
a different circle the radius was like 8?
Well, then the arc length is going to change also.
But does that change like the size
angle?
of a radian?
No, because there's a relationship there. They'll always be, those two will always be related. If you make the circle bigger, both of them are going to get bigger. To find the angle, you just do S divided by R, like you were just saying. If the radius was 12 and the arc length was 6, that angle would be 1/2 radian, half a radian. If this was 18 and this was 6, that'd be 3 radians. Radians, this is weird.
A big circle?
No, that's this. Radians are
I mean, you
unitless.
guys have that super chart?
Like if you measure a circle an angle in degrees, the units are degrees. Radians, if it's in radians, it's technically unitless. Because if you divide S by R, that's feet divided by feet, there's no units. Or inches divided by inches, there's no units.
Are we learning that?
Yep, we're getting there.
What?
That yellow one.
Ew, I don't want to look at that.
Why there's square roots?
Hey, you can put a negative.
So let's figure out how many radians are there in a full circle. That's very important. Because you know how many radians are in, or how many degrees are in a circle, right? 360.
See, I don't know what you're
Who's your geometry teacher? Jeez. There are 360 degrees in a circle, right? Well, how many radians is that? We could figure it out pretty easily. So if I do that, let's start with this. To make a circle, if I start going, like, when do I stop? It goes all the way around and it stops back on itself, right? That's a 360 degree angle. Or, it's not a very good circle, I don't know. So when I'm doing this, what is the arc length of this? Arc length meaning from here around to here. How far is that?
60 degrees.
What part of a circle is that?
The circumference.
Circumference, and what's circumference equal to?
Pi times
Pi
r
r
squared.
squared.
That's area.
2 pi r.
2 pi r.
I don't remember this.
Well, good thing I'm not in geometry.
Yeah. Circumference is 2 pi r, right?
I wonder how it's all those stupid things are.
I was just thinking, sorry. I'm looking at my notes trying to decide what I wrote. Anyway. So 2 pi r is the circumference of a circle, right? Well, isn't that, in this case, that is my S, that's my arc length, because we did a full circle, right? So I could write S equals 2 times pi times r. Right.
Right.
Sure.
I'm kind of doing this in a weird way. Oh well. We're trying to figure out what theta is. Just real quick, we know theta equals S over R, right? So then, if we multiply both sides of that by R, does it S equal theta times R?
Yeah.
Yeah.
And if we substitute that in for S here, I'd have theta times R equals 2 pi R.
Oh my gosh, calculus.
Divide both sides by R. This is just algebra.
Theta equals 2 pi.
Theta
Well, there's
equals
multiple letters
2
in there.
pi.
So that will help it every time.
All I did, I knew
Holy shoot.
my arc length was 2 times pi times the radius, because that's the circumference of the circle. S equals 2 pi R. From up here, I told you that theta equals S divided by R. Therefore, if I solve for theta, or so I solve for S actually, S equals pi, or theta times R. Substitution, plug that in for S. Solve for theta, theta equals 2 pi. Always, in a circle, the number of radians in a circle, 2 times pi. So you don't really ever say, oh, 4 radians. It's all usually you have pi in your answer for how many radians an angle is. So we said, oh, how many radians is this angle? Usually, like I said, it's pi. This one was pi over 2. It always has pi in it because of the whole circle thing. Not always. You could say 3 radians. It's just a little less than pi. Make sense? Right? Remember, pi is a number.
Yeah, it's right there.
Yeah, right there. So there are 2 pi radians in a circle. Whoopity-doo. So all that means is we could start telling how many radians that angle is. So if there are 2 pi radians in a circle, what is the measure of that angle?
Of 4 pi. Half a radian. Half pi.
Yes.
Yeah, half pi is 2 pi.
We write it as pi over 2.
Why?
Yeah. Because a full circle, if I do a full circle, that's 2 pi radians.
So half is pi.
So half a circle, if I go a half of a circle, that's 1 pi.
So half of a half is...
Half of a half would be
Half a
half pi. 1 half pi.
I have to literally picture a pi.
Let's look at a picture.
Yeah,
I should have had these printed off. Long weekend. Basically, I'll just draw the picture. You're going to get what's called a unit circle. You may have heard of this or seen the picture of the circle. Where you'll say, if I have an angle that's just as here, that's either 0 radians, right, no angle. Or if I go all the way around, That's 2 pi radians, right? If I go halfway around the circle, how many radians is that? 1 pi. 1 pi. It's half of a full circle. Right, from here down to there, it's half a circle, that'd be pi. So then if I do just a quarter of a circle, that's pi over 2. If I go 3/4 of the circle, I went down here,
Pi and a half.
pi and a half, 1.5 pi or 3 pi over 2. Alright, there's a full circle. Well, then you can start. I'm going to give you a picture of this, you don't have to draw it.
Okay.
We can start cutting those in half. And we can start going, oh, if I go between here and here, what angle is that? So a 45-degree angle is pi over 4 radians. I could go to a 135-degree angle. Right there, if I went all the way to there,
Pi over half.
it's between half and 1.
Over.
You guys are good at fractions.
Dude.
Yeah, 3 pi over 4, good. 3/4. Right? And you can go around, and then we can do halves of those. And we
We're
can
not good.
fill them all in. Oh, we are going to. We're not going to sit here and do it, though. I'll just give it to you. And it looks like this. Once my computer gets fired up here, which will probably be in about 20 minutes. I don't know how this thing works. Yeah, so like if you go to here, that's 5 pi over 4 radians. This will show 3 halves and 4 halves. 4, 6, 7 fourths. 7 pi over 4. And then you can break them in half again and you can just get different measures of angles in radians. Remember complementary and supplementary angles in the geometry?
Yeah.
Or complementary angles? They're like, oh, hey, your hair looks nice today. Oh, nice. That dress looks nice.
Isn't it like they're on the other, I don't know.
They add to 90 degrees. Remember complementary angles? Common pictures like that. Here's A, here's B. A and B equal 90 degrees. Those are complementary angles. Remember supplementary angles? Yeah, those add to 180 in degrees, but now we're going to do radians and do complementary and supplementary angles. Now we're scratching. Oops, that wasn't my next thing.
Look at all down
So what do complementary angles add up to in radians?
2 pi over 2.
Pi over 2 is correct. We'll use alpha and beta for our 2 angles.
What?
Those are just Greek letters, like pi. Alpha is like an A with a little thing that pops up like right there, and beta is like almost a cursive B. They'll add up to pi over 2. That's just the same picture as we drew before. If you have a right angle, alpha and beta add up to pi over 2. Just show you what I was talking about, and I'll print you off one of these, and you'll eventually have to memorize it. Boom. A 30-degree angle is pi over 6. You'll learn what these numbers are probably tomorrow. Yeah, these are just the angles. Pi over 6, pi over 4, pi over 3, pi over 2.
It's the same as up there.
Oh yeah, it's the same as up there. It has to do with cosines, sines, and tangents, which we'll get to
The
tomorrow.
stuff's coming back.
And it's coming back in full force.
So there was a point to that in geometry.
Yeah. Oh, wait till next year. You're like, what? We have to know that? Calculus is kind of like
Everything thrown
everything that you've ever learned in your entire life about math. All kind of
into a circle.
all kind of comes together. No, this is this is just this. Except for stats. That's mean, median, mode. No one ever really cares about that again. Okay, so complementary angles at pi over 2.
That was like fifth grade. I know.
Supplementary. My handwriting's horrible today.
I got it.
What do supplementary angles add up to?
180.
Nope.
Oh, and
Pi over 2.
Pi.
pi.
That alpha plus beta equals pi. So, then, knowing that, can you tell me the complement? What is the complement of 2 pi over 5? You know what that means? Like if I asked what is the complement of 40 degrees?
It would be
50 degrees. It's the angle that makes it add up to 90. So in this case here, what is the angle that will make that join up with that one to add up to pi over 2? Now, you're probably not going to be able to do it in your head. You're going to need a method. No, we don't need that yet. Well, think about it. If I said, what's the complement of 40? What do you do in your head? 90 minus 40, and you get 50. So what are you going to have to do for this?
subtract
Pi over 2 minus 2 pi over 5. And then it becomes a review of
Negative.
subtracting fractions. If you don't know how to subtract fractions, you cannot do this.
We're going to come on there.
Yes, you have to go find the denominator, of course. Which is 10. That one's multiplied. So we got 5 pi over 10 minus, multiply that one 4 pi over 10. So the answer would be pi over 10. Seems wrong. Or I did it wrong in my notes or something. Yeah, I did. Yep, I got it wrong. That's right. What's the supplement of 2 pi over 5?
Pi minus
3 pi over. I don't
Well, how are you going to do that? If I
know.
said
Pi
what's...
over pi.
Huh?
Is it pi over pi?
No, that's 1.
pi over 5 minus.
If I said what's the supplement of 37 degrees, what would you have to do? 180 minus 37. So you got to do pi minus 2 pi over 5. Pi over 1.
Oh, pi over 1. 3 pi over 5.
What is it? 3 pi over 5? Yeah, that makes sense. Because that would be 5 pi over 5 minus 2 pi over 5 equals 3 pi over 5. So that's easy. Finding complements and supplements. Complementary angles, supplementary angles. Just working with fractions. Easy deal, right? Now here's the next thing is so easy that sometimes people get so confused by it. So I will try to choose my words very carefully. It's called coterminal angles. What's terminal mean? The end. So all this means is the angle ends in the same spot. So what I mean by that is, if I were going to create an angle, I'd start here. Someone tell me when to stop. Oh, stop right here. So I'm going to draw that. That's the terminal side of that angle. We'll call this angle alpha.
It's alpha couples.
Can I create another angle that's different than alpha that stops in that same spot?
Yes, you can go the other way.
You can go the other way. I can start here and go this way and go. Stop! It ends in the same spot, but it's a different angle, isn't it?
Yeah, it's
This way, we'll call it beta.
Wait, what is it? Beta?
Beta,
Keeps me saying beta.
yeah, they use Greek lettering. Delta alpha, beta, alpha, gamma. Bag. What do you know about alpha and beta in this case? They are coterminal, and if you add them together, what should you get?
360.
2 pi.
2 pi.
Oh my gosh, I forget we're not in
We're not in degrees anymore. Dorothy. So if I told you in this picture that alpha was equal to pi over 4, could you find beta for me?
I'm like a fish.
It is like a fish. It is.
Why did drawing like an A with an angle eating?
It is that. Yes, it is 2 pi minus pi over 4.
Wait, what is your question?
If alpha is pi over 4, what is beta? If they're coterminal.
You gotta get 2 pi, right?
Yep. What'd you get?
2 pi over 4. I think.
Yeah. It'd be 8 pi over 4 minus pi over 4. Did you get 7 pi over 4?
Yeah. Why is there a 4 there?
This is not correct. It's just a little technicality here. Which way did I go for beta?
It's negative.
So it's
7.
negative. Even though if you add negative 7 pi over 4 plus pi over 4, you don't get 2 pi. Because in this case, when measuring angles, negative does not mean like negative. It doesn't mean you subtract it. It just means that you measured it the other way. It just has to do with direction. Meaning I went this way, 7 pi over 4. Does that make sense?
Yeah.
So don't think that you're going to add those together and get 2 pi, because you're not. This should technically be like absolute value of both of those. But I'm not going to mess with that. That's actually, yeah, I don't even know if I can technically write that. Because it's a negative. Negative just indicates direction, though. The values, yeah. So those are coterminal angles.
I'm just drinking.
I mean, oh, converting degrees to radians and radians to degrees. Just do that real quick. It's simple.
Look how neat I wrote with the beginning of the year.
You know how many, let's see, how do we do this? I could just tell you how to do it. Just do it that way. Don't try to figure it out why it works or anything.
No, this is how you do it.
Okay, if you want to convert from radians, or we can go either way first. Let's go from degrees to radians. Simple. You multiply by pi over 180. If you want to convert from radians to degrees, yeah. You multiply by 180 over pi.
I'm gonna get this over.
Easy way to remember that. I knew you were going to say that. Let's say I have, give me degrees.
37.
37, right? That's gonna be an ugly answer. I have 37 degrees. And I want to convert it to radians. Well, the way you remember which one to do is a pi over 180 or 180 over pi. You want the units to cancel out. So you want to have degrees on top and degrees on bottom so that the degrees cancel out and your answer is in radians. So that's how you know you want 180 degrees on the bottom and pi on top. So you know then degrees cancel and your answer would be 37 pi over 180. And you could reduce that if it was reducible, but you can't, so that would be your answer. Picking a different one, like 60 degrees, convert that to radians. Multiply by pi over 180.
3 pi over 6.
Pi over 30.
Maybe 60 pi over 180, which reduces.
So
That's
1/3.
0, 6, 1/3, yeah, pi over 3. What? I haven't written on paper in like 7 days.
Us neither. The last 3 days.
Here are like 8 days. Yeah, it was Monday last week. That's the last time I wrote something on paper. Cool. So converting from radians to degrees. Let's say you had
Just keep a journal.
3 pi over 4 radians and you want to convert it to degrees. Well, you want your answer to be in degrees, so you want degrees on top. If you have degrees on bottom, your units would be 1 over degrees. That doesn't make sense.
Okay, so then what you want it to be, you want on top.
Yeah. So multiply by 180 over pi. You know how to multiply fractions, right? Cool.
Across.
Yeah. Well,
640.
if you're going to have a pi on top and a pi on bottom, what's going to happen?
It's gonna cross out.
Yeah. So 3 times 180 is 540. Divided by 4.
90.
No, more. 100 and something. 106. No, 130.
Oh my god, they're doing it.
135.
You're turning into Mr. Boss real.
You're right, by the way. 135 degrees. That's how you convert them. Make sense? Easy enough?
Yeah.
That's easy, right? So all this today. Any questions? We'll get harder tomorrow. Don't worry.
So we can stop.
'Cause I need to look
Yeah,
at
we're going to
that.
stop right now so I can give you some problems to check out. 4.1. These are highly recommended.
Maybe I'll go home and do one for once.
One more thing on coterminal angles. Because it'll tell you to find the coterminal angle. So it'll be like, oh, here's pi over 4. Find two coterminal angles for that. Well, one of them, you go this way, right?
Just be a positive and a negative.
Wouldn't it be negative 7 pi over 4? That's one coterminal angle, right? What's another one?
0.
No, 7 pi over 4 would go down here.
Pi over 4.
That's the same one. Negative. So what you can do, you can go all the way around the circle and then stop there again. So that would be a full 2 pi,
2 pi
plus another pi over 4,
Oh my gosh.
which would be 2 pi plus pi over 4. Oops, pi over 4. So that'd be 8 pi over 4 plus pi. 9 pi over 4. So basically you do 2 pi plus that number and 2 pi minus that number to get your two different answers. Okay. Let's do number 15. You know about quadrants, right?
Yeah.
Okay, good. We can skip all those. I don't want to give you too much because then you won't do it. We're not doing anything in degrees. I'm just going to assume you're masters of degrees. that's it. That's it, just 4. But there's A and B for each one.